Risk is a function of severity and frequency. The severity of explosion is high and generally leads to the destruction of property or mortality. Severity of explosion damage is also difficult to mitigate. Our only option to mitigate overall risk is to decrease the frequency of an explosive atmosphere and, barring that, manage and control the apparatus and processes in the vicinity where an explosion is possible. The classification of hazardous zones seeks to decrease risk by determining the frequency and duration of the presence of an explosive atmosphere. The risk of explosion cannot be allowed to hinder production, and the dedication of areas dependent on the frequency and duration of explosive atmosphere allows for the approval of processes and apparatus for the zones in contention. This presentation seeks to arm those who dare venture into the subjective matter of hazardous location classification with the knowledge required to make decisions regarding the dark art of zonal classification in all its vague and unconcise glory. The information in this presentation is set out in a step-by-step format to allow easy navigation of its contents and provides an instructive checklist on the method of allocating hazardous zones. Please keep in mind that the contents of this presentation is applicable to flammable dust and vapor only. The risk of explosion and fire damage is a severe one. Defining conditions which tends to cause the presence of an explosive atmosphere allows for the selection of safe apparatus within the defined areas. The classification of these zones is necessary to understand the areas that are most likely to cause an explosion or fire hazard due to the frequency of an explosive gas or dust atmosphere. The hazardous zone will also inform the apparatus that can be used within themselves. The existence of an explosive atmosphere can be attributed to the presence of suspended combustible dust or combustible vapors. The primary specifications concerning the aforementioned topics are the BSEN IEC and SANS 60079, 10.1 and 10.2 and their derivative SANS 10.108. It's clear to see that the fear of simplification of the standard, given its subjectivity, hinders international communities from assimilating the standard, and they choose to adopt it instead. The adoption of the former two standards is a testament to the inability of the SANS 10.108 to perfectly or even adequately portray the requirements of hazardous zoning. Intrigue and ambiguity in standards are generally seen as the weapons of the engineer. However, the so-called loopholes in this particular South African standard feels more like bullet holes, and the engineer is forced to fill in these information gaps with international standards, analogical reasoning, and critical thinking. The first step in the process of determining hazardous classification zones is to determine the relevant materials handled on site. Materials are grouped into two main subcategories, that is, flammable liquids that give rise to flammable vapors and flammable solids that give rise to flammable dust. Flammable vapors and dust are the only two substances that can give rise to an explosive atmosphere. Flammable liquids are classified by group and flammable dusts are classified by class. The class definitions are defined in the SANS 10.108 explicitly, but the groups are not clearly defined and are based on other standards. The groups do, however, play a role in apparatus selection. It is critical to note that the classification in terms of hazardous zoning is separate from the classification based on closed cup flashpoint that we are familiar with. Classification of specific materials are found in SANS 10.108. Useful reference information for the classification of flammable vapors may be composition, flashpoint, boiling point, vapor pressure, upper and lower flammable limit, and auto-ignition temperature. An important factor to consider is relative density to air to determine rise or sink. Note that the density of vapor is different from the density of the liquid. Sources of release of flammable materials and substances which could lead to an explosive atmosphere should be established. These sources of release could be constant, primary, or secondary, and are usually indicative of the zone. However, the subjective definition of each zone as shown in the next slide should be the sole manner in which zones should be classified. The rate of release and forms of release is also critical to understanding the limits of the hazardous zone. Extensive information on sources of release and their implications can be found in the international standards. The application of hazardous zoning is only as good as its definitions. Given the subjective nature of the topic, the zones are defined as Zone 0, Zone 1, Zone 2, Zone 2.0, 2.1, and 2.2. The first three zones are for explosive gas atmosphere, and the last three zones are for dust atmospheres. It's dependent on frequency and for the length of period that it can create an explosive atmosphere. The cowardice of the authors of the SANS 10108 standard is evident from their fear of clearly stating geometries, limits, and distances, or even providing a method of determining these distances. The SANS 10108 uses the international standards as a crutch in this regard to prevent the explicit demarcation of hazardous zones. The international standards provide an excellent resource on the suggested geometries of flammable vapors under varying conditions. The zone geometries of dust areas are specific to conditions, applications, and processes. The intended method of determining the extent of hazardous zones is to first identify the volumetric release rate of the potential leak and using a graph to determine the hazardous distance depending on the characteristic release. The release could be heavy gas, which is heavier than air and falls down, diffusive, which is lighter than air and floats up, or jet, which is forced expulsion. Selection of apparatus is generally the next stage after the determination of hazardous zones. The input information of hazardous zoning and apparatus requirements is used to generate a safe layout for machinery positioning. The complication of the method of selection of safe apparatus is that there are too many authorities. SANS 10108 contains a table detailing the equipment rating required for each zone and material group. The above slide shows typical European safety markings for safe equipment. It is critical to note that the geometries of hazardous zones are indicative of real-world positions and as such are three-dimensional. The drawing layout indicates the spatial dimensions while the zone classification accounts for the temporal dimension. The zones each have their own preferred hatch patterns from the international standards as shown above. The process of determining hazardous zones is simple. First is the identification and classification of hazardous materials. Possible sources of release need to be identified and classified by zone. The geometry and extents of the zone can then be determined and the required apparatus can be selected in accordance with the zone and material classification. While noting the vagueness of the standards and the massive space it gives for the engineer to make decisions, it must still be noted that the onus falls on the engineer or preferably multidisciplinary team to make the best decisions and back it up with reasoning, as the risk of explosion is always there and negligence or incompetence can lead to disastrous results. Thank you.